Hey folks, another short video. Similarly to how we discussed calculating enthalpy changes in chemical processes and entropy changes in chemical processes, we're now going to discuss free energy changes accompanying chemical processes. And as I said, this will be very short because in the other discussions of entropy and enthalpy changes with chemical processes, our process for calculating free energy is very similar. So our standard reaction free energy is the quantity that we're interested in talking about free energy changes with chemical reactions. And it's the same formula that we've discussed before, the sum of the products minus the sum of the reactants. We remember also that Hess's law applies. So if we have multiple steps in a mechanism, we can add those up to get our total reaction, and we add up the corresponding free energies. And similarly to our delta S, for H plus, we set that equal to 0. Set to 0. So this is not in actuality, just as was the case in entropy of the formation of an H plus ion in an aqueous solution, we set this to 0 to be a reference point so that we can relate the formation of ions in an aqueous solution relative to that of H plus. Okay? So once again, that is a reference value. And similarly, where we've set the, I'm going to write that as the standard molar entropy of formation, or really just we'll say the entropy of a formation of an H plus aqueous is also set to equal 0. I could not write that formula at all. Let's try that again. Equal 0. So what I want to stress, though, in this video, most of the time we're not going to necessarily get exactly at the molar free energy of a material. So oftentimes what is more useful for us is recognizing the following, that the standard free energy of reaction is equal to the standard enthalpy of reaction minus T times the standard entropy of reaction. So oftentimes we'll have these quantities more readily available. So we would do that, products minus reactants calculation for the enthalpy. We would do the products minus reactants calculation for the entropy. We note at what temperature this occurs, and thus we can calculate the free energy of that particular reaction. And of course, noting that if that value is less than 0, the reaction is spontaneous. If the value is, let's see, let me make sure that I'm writing these. I got confused because the way I wrote it. Yes. Okay, so if delta G is less than 0, it's spontaneous. If the free energy of reaction is greater than 0, it's non-spontaneous. And in the coming weeks, we're going to start discussing equilibrium. So we should recognize if the free energy of reaction is 0, then our reaction is at equilibrium. Okay. So that's all I wanted to say about that, and we'll do a couple sample calculations of this in our live lecture. I'll see you then.